Today, I'm joined with my friend here, Sean Massey, to talk about lessons learned from building global Horizon environments on VMware Cloud and AWS. Dennis did a fantastic presentation before us, so fantastic, in fact, there's quite a lot of overlap. So I hope we can bring some a little more detail to what he talked about. But overall, Dennis, that was a fantastic presentation and a good overview of what the options out there. We'll hope to go into more detail on VMC, obviously. So, as I mentioned, I'm Andrew Morgan. I'm a staff engineer in the UC office of the CTO, and you can find me on Twitter there. As you can see from both of our Twitter handles, we were kind of late to the party. That's why we had to put our middle name in there. And my colleague.
All right, I'm Sean Massey. I am a Cloud Staff Solutions Architect at VMware, and also on Twitter. So
very good. So just to give you an idea of what we're going to cover today, we're going to give you a little deeper overview of what VMware Cloud and AWS is, what it looks like and what it feels like. Some use cases specific to Horizon 7, obviously. An overview of what Horizon 7 on VMC will look like. A demo, or at least an overview of Sean's own working environment in AWS, which I'm very jealous about. He's got more pods than I'd possibly know what to do with. Nobody will give me budget. And some lesson learned, obviously, from the deployments that we've done, either in Sean's lab or when we were initially testing Horizon 7, and even some Citrix ones in there too. So an overview, I suppose. Oh yeah, no, it's me. What do you get when you take VMware and AWS and put them together? Well, you get the world's first-class cloud and the world's first-class enterprise hypervisor and software vendor, and you marry them together. You're taking an on-prem solution that we're all very, very familiar with, most customers are running today, and we're taking the flexibility and services that are running in AWS and marrying them together, allowing you to have a service and a platform that you're very familiar with, that you can connect with the new services that your business is demanding, and allow a seamless integration between both of them. So when these two came together and I first got access to it, I was very, very surprised at how easy it is and how feature-rich it was. I mean, before joining VMware, I'd done some work in AWS with Citrix Technologies, similarly with Azure, and one thing that struck me throughout that process was every time you went to a new cloud, it was an upskill. I love the Microsoft documentation specifically for Azure, because on every Azure page it tells you how long it's going to take you to read that document. And then you sum up all of those documents you need to read around networking and groups and VM sizes and all the rest, and you've lost days of your time. The beauty of the solution that these two companies have brought together is you probably already know how to use it, because you know how to use vSphere. VMware Cloud and AWS is it's basically infrastructure/platform as a service, where you're taking a solution that we already have, and we're providing it as a service running in the AWS data centers on bare metal. So it's all of our stack end to end as a service deployed to you. It's consistent, as I alluded to already. It looks and feels, passes the sniff test just like the on-prem product. If you can use the on-prem product, you will not get lost in VMC. It's identical. It's very portable. One issue that you'll often find is when you're sizing any kind of VDI environment or even server environment in a cloud vendor, you need to figure out what your VM currently looks like, what size you can possibly shoehorn it into for the least cost possible, and then see if it actually performs the way you expect it to. You don't have to worry about any of that with this. You can take whatever weirdly sized VM you have and stick it into VMC without resizing it if you wish. It just works. They're portable. It's integrated, obviously, so you've got an integration both between what you're doing on-prem and also what you're doing in AWS as well. You can connect your on-prem infrastructure to your VMware Cloud and AWS infrastructure, and you can also connect your VMware Cloud and AWS infrastructure to your native AWS services. So you get that myriad of all services coming together. And then finally, it's any app, just like on-prem. You can run containers, you can run VMs, you can do whatever you want with it. So, I mean, from a management and kind of provisioning and what you have to do as a customer versus what VMware has to do, we pretty much do everything from bare metal up. So we'll create your account in VMware Cloud and AWS. We'll provision the bare metal hardware that you're going to use in that cloud. We'll plug in the networks that you require. We'll create the management networks that we're going to manage ourselves. We provision the whole thing from end to end, creating the vSAN cluster, creating everything else. And at the end of that initial experience, you'll have a cloud instance running for you that you can connect directly into vCenter and start working with. We manage the hosts, we manage vCenter, we manage NSX. You'll often, if you check in the events, you'll see our fleet management services connecting in and checking the health of the environment to make sure everything is okay. So we are actively managing that environment to ensure it's working to the best capacity. And in regards to maintenance as well, we will schedule the maintenance that needs to happen for these VMs. We will connect in, and even as Dennis alluded to earlier, we can do a 3-node cluster, and most people with vSAN will know that that's generally not a good idea. We'll actually loan you a node while we're doing maintenance in that scenario, so that you can stretch the cluster out, and then we'll take it back off you when you're finished. So from a maintenance point of view, that is how that is managed and how it's carried forward. And of course, because of the availability of AWS, which is pretty much everywhere, we're actively starting to push it out. Anything there in green is already available, anything in blue is coming this year, and anything in yellow is coming next year. So it's expanding and expanding quickly. So this is my favorite slide, because this is what VMware Cloud and AWS at least was to me. It's not an upskilling operation. It's not trying to shoehorn services into a specific size. It's cloud for civilized folk. You can do, if you know how to use vSphere, you know how to use VMware Cloud and AWS. There's no retraining. We don't impose bottlenecks on IOPS or network storage or anything like that, or networking or storage. We don't do any of that. You buy a host, you use that host to your own usage, as you see fit. You need more hosts, you add more hosts. You don't want hosts anymore, you can remove them back out again. It's very, very, very efficient and easy to use. And not only that, it's extremely fast as well when Sean goes into the sizing of the environment, which we'll do now.
Next.
Absolutely.
All right, so what we want to do is give just a little bit of an overview of the physical infrastructure that backs VMware Cloud on AWS. So what we're going to talk about, there's actually 2 types of physical infrastructure. We're going to only talk about the one that's really used for VDI and end user computing environments. There's another one that just came online a couple of weeks ago that is really more for like big data type work sets. So what we have here is just some of the base sizing information for what we call our i3 nodes. The i3 nodes are dual socket host with some really powerful Intel E5 processors, 18 cores per socket, and 512 gigabytes of RAM per host. So as you can see here, in a 3-node cluster, you go from anywhere from 108 cores that are available all the way up to 576 cores in a 16-node cluster, which is the max that we can do per cluster in VMC. You go from 1.5 terabytes of RAM to 8 terabytes of RAM usable, right? So this can fit almost any EUC use case that you can throw at it. From a storage perspective, we use vSAN all flash on the back end. That's the main storage for the i3 nodes. These hosts have NVMe drives, 8 per node, right? So that gives you anywhere from 24 NVMe devices to 128, 30 raw terabytes to 160 raw terabytes. So this is really fast, really scalable, right? These NVMe drives are encrypted, and in our SDDCs, in the first cluster that you can have in there, you have your management components running on them. Those management components only use about 0.9% of your total space available. So it's just a small fraction of your usable capacity geared for management overhead.
Networking, okay. So networking is tricky, particularly if you're not a networking person and you log into a cloud for the first time, you're not going to have a good time. The way we separate out networking in VMC is relatively simple. We have 2 networks by default. We have a management network, which contains the appliances that we manage. So that's vCenter, that's NSX, and that's the hosts. So within that management gateway, when you're configuring your SDDC for the first time, you assign it a subnet that doesn't clash with your local subnets, basically. And from that point onwards, you then have your compute pools running in a separate network. Within this separate network, the compute pools, you can spin out as many segments or subnets as you wish, and you can isolate the traffic as you would, just like on-prem. You assign it an IP address range, you choose whether you want DHCP, and basically off you go. And obviously to highlight, like, this is heavily firewalled with NSX Edge, and you've got, your logical switches and your firewall and VPN. If we go to the next slide, you can actually see what this looks like. So from an NSX management point of view, it's very simple. I mean, you have your segments, you have your VPN, you have your NAT, all the expectation all the things you'd expect to see in a cloud. And as I mentioned, segments are your specific VLANs inside your compute resource pool. We have the gateway firewall and the distributed firewall. You can group things by services or by groups of devices. And then you've got all the additional things like DNS, public IPs, everything you'd expect to find in the networking, but very, very easy to get around if you've never even seen NSX before. And then when it comes to the segments itself, so in the NSX management console over here, in VMware Cloud and AWS management console, you see the segments that you've created with your IP addresses, and this is how they appear in your SDDC. They're just what are called opaque networks from NSXT. So you can just choose that, spin up your VM, and off it goes. It's running in that network location. And just to highlight, we can enable or disable DHCP, which is particularly important for the other vendors' components.
Yeah, so key thing to keep in mind here is we've really simplified networking for this. It's one web page to go to as part of your SDDC console. It's real easy to create your subnets. It is real easy to create your firewall policy. And you don't have to have a CCIE to do networking up here.
No, I figured it out, and I'm useless. I failed the CCNA 3 times before I passed it. So there you go. I managed it. So I mean, in regards to connectivity, you can access it via the internet via public IP addresses, and you can NAT behind that for management and workloads. By default, the vCenter that you're going to provision the first time is going to be a public IP address until you actually wire up your VPN. So that's how you access it in the first instance. We have the stateful edge firewall as well for access to whatever, and you can sub-segment groups. In regards to connectivity to on-prem, you can do your IPsec VPNs, or you can also do AWS direct connects. So IPsec VPN might be fine for a POC, but if you actually need the throughput of a direct connect, that's when you'd start to wire that up. And then actually the connectivity between VMC and AWS is via what's called an elastic network adapter. Very, very fast. It connects into your AWS VPC where it can access its services in the same availability zone, and regional services and that kind of stuff. So just to highlight that, it's very, very easy to connect to as well. And initially, it's internet facing, and then once you've got your VPN wired up, you take it offline. The DNS is managed by us as well, so once you do that flip, we just reroute the IP address to the local address. That's why it's critical that when you're deploying the management network that you make sure it's not a subnet that clashes with local.
All right, so let's talk about some use cases for Horizon 7 on VMC. Right now that we have an understanding of how the VMC platform works. So there are, as we've defined it, 6 primary use cases for doing Horizon 7 on VMC, right? Big one, disaster recovery, business continuity, app locality, so as you move cloud apps out or move apps out to the cloud, you can keep the users' desktops close to them. Data center expansion, so as you start to expand your data centers into the cloud, same principle. Quick POCs of Horizon 7. So if you have customers, if you're a consultant or if you are a end customer organization that wants to try out Horizon and you don't have any spare hardware, or you're digging through the pile of old servers that are about 10 years old, you can spin up a quick POC, do a 1 node for 30 days, and you can try out Horizon real quick. It's real quick to get set up and easy to go. Temporary or burst capacity, so if you have seasonal workers, you don't want to have that capacity sitting idle in your data center, then you can set up a SDDC, put Horizon out there, and they can connect out through that, and you can treat them as OpEx. And finally, global Horizon deployments. Now, as you saw a couple slides ago, the footprint that we have for VMware Cloud on AWS is basically wherever Amazon has a region. Either we have it there today or we're going to have it there in the future. So if you have customers that need global deployments, but they don't want to have to worry about data center space, or they don't want to have to worry about data locality laws, you can spin up an SDDC and put desktops in those regions without having to provision hardware everywhere, or without having to find data center space, or worry about any of the complexities of on-prem IT. So when we talk about data center extension and migration, we're talking about three main things, right? App locality, so as you put applications into the cloud or you migrate them there, either on VMC or in native AWS services, you can put your desktops close to them, right? Maintain good app performance, because that's key to having a good user experience. Temporary desktop capacity. Hey, I've got 500 interns starting on Monday. I need someplace to put them, right? They're not going to have, you're not going to get them laptops. You don't have capacity in your data center. You can spin this up. You can burst to the cloud. And finally, proof of concept and test, which talked about on the last slide. And then business continuity and disaster recovery. So, typically, in my experience, a lot of organizations don't want to pay for DR for EUC, right? They look at the price tag for 2 and they go, we need to cut that back. So with this, you can have on-prem Horizon. You can have a small environment running in VMC, kind of the bare minimum with your key services and Horizon running. Then when you call a DR event, right, you already have this running. All you have to do is add nodes and start spinning up desktops. All your other services are there and ready to be used. So your time to recovery goes down significantly. You don't have to, validate that everything is running in the secondary data center, restore from tape. You don't have to pull out the run books and leaf through them. It's just a matter of, hey, we have this running, we can go with it. And you also don't have to have a second data center with capacity sitting idle, because you can go with the bare minimum that you need to get this to get what we call a pilot light environment, and then you just turn it on when it's needed. All right. So when we talk about Horizon 7 on VMware Cloud, it's a platform as a service offering. VMware manages the underlying infrastructure. The organization that purchases it manages Horizon 7 and their desktop pools. Now this differs from what we offer on Horizon Cloud on IBM or Azure, because VMware or the partner is managing the infrastructure and the Horizon stuff, and the customer that's purchasing it is managing their desktop pools. Now, for those of you who like to read public roadmaps, we have kind of slipped something in the VMware Cloud on AWS public roadmap about some sort of desktop as a service offering based on Horizon 7. Kind of keep an eye out. There will be more coming on that. So, what do you get for Horizon 7 on VMC? Well, you get really, the benefits of the software-defined data center platform. It's up and running in a few clicks. Right. You can easily migrate them from on-premises to the cloud using our Cloud Pod architecture. And we support almost everything in VMware Cloud that we support on-premises. So there's very little to no staff retraining required. There's no retraining of your end users on what to expect from an experience standpoint. And then you can integrate Horizon with native AWS services. So we do have a KB out there on what is supported in Horizon on VMC. It's a KB 58539. So for anybody who's looking at this, kind of keep this KB in mind. It talks about everything that we support and what won't be supported. So as you look at this list here, there's a number of things that we support on-prem and in VMC. Some things like linked clones won't be supported ever. Security server won't be supported. One I want to highlight is vRealize operations for Horizon. That wasn't supported, then it was, then it wasn't again, and now it is. But if you do the Universal licensing, you have to talk to your SE team because that universal license does not include the keys for VROPs, as I've been told. So it depends. So when we look at the hybrid and multi-cloud world, we have this thing called the Horizon Cloud Management Console. Dennis, I believe, spoke about it a little bit in his last presentation. We have this item called the Cloud Connector that kind of sits as a bridge between Horizon 7 on-premises and Horizon 7 on VMware Cloud on AWS, and it will pull information into this Cloud Management Console. Now today, for Horizon 7, it does license management and automated install. Some of these other items are things that are under development and may or may not make it into the final product. So, and then finally, the automated install of Horizon 7. So back in March, when we did our last Horizon Cloud update, we did come out with an automated installation tool for Horizon 7 on VMC. So you have to bring your own Active Directory, you have to bring your own SQL Server for app volumes and the events database. But once you have those, it will provision a full Horizon environment that's highly available, 2 connection servers, 2 access gateways, 3 app volumes managers, and it will integrate it right into Horizon Cloud for you. So this is basically a push-button Horizon deployment. Right? Once you get this in, you can start provisioning your networks. VMware can create, or this tool can create the networks for you if you have a brand new SDDC, so you don't even have to pre-create those. And VMware will provide the server templates. So you don't have to even provide your own image or your own servers for this. This is a full deployment.
Must you bring your own load balancer solution?
Yeah, you will have to bring your own load balancer.
And we actually touch on that a little later as well, of some of the services you can leverage outside of to get to that.
Yeah, so it will do the built-in load balancing for the UAGs, but because that's built into the product. But for the load balancing for app volumes and the connection servers, you will have to provide some sort of load balancing for that. All right, and then beneficial AWS services, right? So
how convenient.
Because we are, connected to a VPC, we can take advantage of a number of built-in AWS services. So, we can utilize RDS for our databases. We can utilize ELB for our load balancing. We can use AWS Directory Services. And with that, FSX for Windows File Services. Now, we can also utilize Route 53, but Route 53 doesn't actually depend on any of the other AWS services or our VPC, right? So we can utilize that to balance between on-prem and VMC-based environments. It does not require a VPC to utilize. All right, so.
Architecture. Okay, so out of curiosity, how many people in the audience have run a cloud pod architecture today with Horizon? Does anybody? Okay, so a couple of them. Okay, so you're going to be bored for about 5 minutes. The way Horizon scales across territories and across data centers is via the cloud pod architecture. The idea is you take a block of compute called a pod, and then you aggregate all that data across the pods into a cloud pod. And what that allows you to do is have pods in different locations, servicing users, and whatever balancing mechanism you use. Once a user hits a connection server, they can be branched out to whichever pod, and they're all aware of each other. That's how cloud pod works. So there's some scalability numbers a little later, but just to know that that's how we do scalability across data center today, and it's exactly how we do it in AWS too. To give you an idea of just how far this goes, these numbers keep increasing as our customers get bigger and bigger. So presently, 250,000 sessions can be supported in a cloud pod federation. Up to 50 pods, 10,000 sessions per pod, 15 sites, 7 connection servers, 350 total connection server instances. So
it's big.
It's massive, and we have customers touching on that already. As I mentioned as well, the way a cloud pod architecture works is a concept of a global entitlement. It's an entitlement to a desktop or an application. And below that global entitlement are a number of pools from each of the pods. And once you request a global entitlement, it will find a resource available from one of the local pods or for one of the local pools, be it application pools or desktop pools, and you will be assigned that to work. Now, there's more stickiness you can configure like home sites, but just to explain, that's how a cloud pod architecture works today, and that's how far it scales. So, is that going to build out? Okay. So the idea behind all this is on-prem today, the way best practices architecture is to deploy a management block, obviously that contains your. This is in a pod. You have a management block that takes care of the infrastructure, keeping your management workloads away from your desktop workloads, and then you deploy a resource block for a subset of users. That's how it looks like on-prem today. For VMware Cloud, what we're doing here, as of today, we are just taking that management architecture and wrapping it up in the same SDDC, leaving obviously our management resource pool, the vCenter and NSX, which is managed by VMware, out in the management network, and then we're assigning users to the resource on top of the management resource pool. And there are some challenges with that which we'll talk about now. Because each SDDC is a single pod, and each SDDC has a single vCenter. Our vCenter by default is a normal-sized vCenter, so it can only scale so far, first of all. Because NSX is a software-based gateway, we do have limitations as to how far you can push this thing. Presently, we're recommending 2,000 virtual desktops per SDDC. And that's for a number of different reasons. It's to do with the vSAN connectivity, it's to do with the packets per second through the NSX gateway, it's to do with the even ARP table limitations. So where we are today is 2,000. But what makes this a little more challenging is if you start going past 2,000 users, you now have SDDCs all intercommunicating with each other. And as I alluded to with the cloud pod architecture, you can land anywhere on that cloud pod and get redirected off anywhere else to actually service a resource. In that scenario, you're going to start getting traffic going across your SDDCs and back again, which is not necessarily a beneficial thing, particularly when it comes to bandwidth costs. So in the background, this is being long thought about, and no commitments today, but there are plans to tackle this in a separate method where we start to look at maybe bringing some of our infrastructure out into AWS, so that we no longer have that pinning of resources in each block, and once the user actually establishes a session, they go from the VPC directly down to each of the pods, addressing that scalability load.
Yeah, and again, for people who like to read release notes, with our last UAG release, we did add support for deploying the UAGs in EC2. And as we had mentioned on previous slides, you can take advantage of EC2 and other services for your infrastructure. So today it is supported to deploy your connection servers and your UAGs in EC2. There is not much guidance around it besides that. We will support it, but there's not much else around it.
Because secretly we're trying to figure it out. But anyway, so
if you want to take the risk and do it yourself, you're more than welcome to.
Absolutely. Just don't tell us. So, networking.
So, let's talk a little bit about Horizon networking. So, Andrew had talked a little bit earlier about, our different networks, right? And how all that works. So, when you deploy Horizon 7 on VMC, right, you're going to carve out a couple of networks behind your compute gateway. You're going to have 1 or 2 DMZs, you're going to have some back-end network for your servers, and then you're going to have some networks for your VDI resources. And this is kind of what that reference architecture looks like. All of these networks here are behind the edge compute gateway. You also have your vCenter behind the edge management gateway. I will call out one thing. We do show the distributed firewall here to segment these networks. The distributed firewall is not included as a feature or as a free feature in VMC. It is a trial offer, and then there is going to be a subscription behind it. So just something to keep in mind. So when we set up Horizon on VMC, the first thing we need to do is make sure our connection servers can talk to vCenter. So there are firewall rules that you will have to set on the management edge gateway to allow this communication. It's not open by default, right? Your vCenter is, fairly isolated and locked down. right? However, it's only basically one rule. It's only port 443, and you can just, typically you'll probably do your whole backend subnet for that, because you'll also have things like app volumes or other services that need to talk to vCenter. All right, so users coming in, right? So users who are coming in externally, who need to get a desktop or an RDS app session, they're going to come in through the edge firewall to your load balancer and NAT and talk to one of your UAGs. So that's kind of what the traffic flow looks like. There will be, when you set up NAT, you just open up the ports that you need and what address they're going to go to. There's no additional firewall rules that you need to set. Right. Internal users who are connecting, they're just going to come in directly to your connection servers, right? So they're going to come over a direct connect or a VPN link. Again, follow a similar traffic flow, but instead of going to a DMZ network and through the UAGs, they're going to talk to a connection server first, and then once they set up their session, they're going to go right to that Horizon agent. Right.
I drew a short straw on this one. Licensing. So, with VMware Cloud and AWS, you have the cost of running the capacity, and you have a data egress cost. Pretty familiar with anything else. It's not the VM capacity, it's the host capacity, how many hosts you're paying for and how many hosts are running. And obviously with Horizon, there is a subscription license required for running it on AWS. Still don't understand that one, but okay. There is, so it's a separate cost, obviously, from the VMware Cloud and AWS service. It's a Workspace ONE Enterprise subscription, right?
Or Horizon Universal. It just got changed and this slide didn't get updated.
Yeah, so, and with that, obviously, you get access to the cloud control plane and the connector, which Dennis explained very well earlier. So, in order to run this, you need to pay for the cost and the compute of AWS, and you also need to pay the Horizon 7 subscription license instead of the current on-prem license. In regards to price points around the hosts themselves, there's currently an offer on, but to give you an idea, it works out at about $4,000 per month per host. Now, when you think for on demand, and obviously if you have a subscription or you aim for longer, or I believe there's even credits that can go towards it. But anyway, to put it into perspective, you're paying for an extremely powerful NVMe-backed host with tons of memory, with cooling and networking and everything else all configured for you and done already for $4,000 a month. That's how it works out. And then as you go further, the cost adds up per host as you go along. Again, you can keep your pilot, if it's a DR scenario, you keep your pilot environment small, and on a DR you flesh it out, or DR testing you flesh it out, and then you squeeze it back in again. So that's the idea behind it. Instead of having to macro calculate how much storage you're going to require in Azure, what size your VMs are, how long they're going to be running, and all of the additional little costs you need to calculate in, you're just talking about data egress and the per host cost. We're at the Microsoft licensing. Yeah, this is just another data center, so you can use your local licenses. Obviously, speak to Microsoft about this, because we only had this conversation earlier. Ask somebody in Microsoft, 5 people in Microsoft this, and you'll get 5 different answers, because it depends on their mood.
And if you're really lucky, you'll get 10 different answers from 5 people.
That's it, yeah. Follow the guidelines, basically. But, I mean, obviously, you're going to need a KMS or some kind of key management service up there. I mean, do people actually use MAK with VDI at all? No. Okay, good. Because you shouldn't, because it's awful. So, that's Microsoft licensing. So, yeah, getting to the interesting bit.
All right. So we actually do have slides after this. All right, so my team at VMware has deployed Horizon 7 in the lab. We actually have it deployed in 4 locations around the globe. The team I'm on is a global team. We have engineers and architects and SEs everywhere, so we wanted to build a lab for them that they could use to demo the capabilities of VMware Cloud on AWS. So we have it deployed in London, Sydney, Tokyo, and Eastern Virginia. Because some of our team travel quite a bit and we wanted to showcase the power of Cloud Pod architecture and what you could do with this, we do have one of those in place. So today I can connect to my desktop in North America just by hitting one URL and going through our London entry point. We've tested this where we've taken a couple sites offline. Before we had North America deployed, I was going through Sydney, right? Or excuse me, through London. We would take London offline. I could go through Sydney and get that same desktop. Now it's a half second of latency round trip, but it was still somewhat usable, right? And showed that yes, even in failure scenarios, we could make CloudPod work on VMC. We have a global Active Directory and file services environment in place to support this, and we're using Amazon Route 53 to provide geo-based or geolocation-based access. Now, what we're doing for Route 53 is actually a little bit interesting because we're not doing necessarily your typical, IP-based location lookup or anything. We're actually monitoring the latency from that user to the different SDDCs that we have deployed. And Route 53 is actually going to make the choice as to which location you go to. We have a blog on this out on the...
We both do.
We both do, actually. In particular, there is a video in one of the blogs showing how this latency-based routing works and what happens when we turn off one of the sites and how it redirects. So this is kind of what it looks like. Right, so our users will connect in through a global URL that we provide. Route 53 will direct them to whatever the best SDDC is, and then they will get access to their desktop from there. And then this is kind of what our lab infrastructure looks like as well. So we have an on-prem site that we're kind of faking that kind of acts as our root. And then we have our 4 SDDCs, and we have our services stretched across them. Now on the back end here, we are using VPN for the connectivity, and yeah. So and then you can see Route 53 on the front end of that. So here's the meat and potatoes. We got about 5 minutes left, so we're going to try to get through all this as quickly as we can. What are the things that we've learned when we've deployed Horizon 7 on VMC, especially at such a large scale? Well, the first thing is just because we have a lot of options doesn't mean we should use them, right? There's a lot of different things we can do. There's a lot of different design decisions, and there's trade-offs to every one of these, right? And some of them are not good or not good in all situations. Excuse me, I got to get that. All right, so a couple of platform deployment considerations that we want to call out here. Active Directory, we're going to talk a lot about this over the next 2 slides, but it is a big deployment consideration, especially since we're talking about cloud, right? Windows file services, we also have a slide on this that we'll go into. DHCP was a deployment consideration, but in our last release of VMware Cloud on AWS, we've actually added DHCP relay support, so it's not as big of a consideration now. Licensing, which we touched on a little bit already, and then everybody's favorite subject, app volumes, right? So this one's real quick. If you're using VMC as a disaster recovery site for your end user computing solution and you have app volumes, let's just say there's not a good way to integrate VMC with the multi-site reference architecture that we have today. That requires some sort of shared external storage, and shared external storage is not supported in VMC. So there are ways that you can get your app stacks up there, but it requires a lot of manual lifting and shifting or switching to VHD. So just something.
Which isn't a bad idea, to be honest. And also, there are a couple of things around that today that will make it a little easier, but the data replication is still tricky. Yeah.
So around Active Directory, there's 4 main considerations, right? Availability of the service. If Active Directory is not available in an EUC solution, you might as well not have an EUC solution, right? You can't provision desktops and users can't log in, right? Performance, right? If your domain controllers are far from the desktop, it's going to impact your login performance. You got to get the group policies. You got to process everything. You got to get your groups and your security tokens. In terms of manageability, some of the options require some sort of external trust. A lot of organizations, at least that I've worked with, have been, single forest, single domain. They're not used to the external trust idea. They're not aware of all the overhead that goes into maintaining group policy in 2 environments or troubleshooting that group policy. So that's an important consideration. Security, though, is probably the biggest one. How many people here have talked to an organization that wants to do cloud, and as soon as you mention putting a domain controller out there, security says no?
Putting the no in
I should
innovation.
see more hands.
Yeah.
This is going to be the biggest obstacle to overcome, right? Security organizations tend to not like putting your source of authentication truth out in a cloud in an environment that they don't control for risk purposes, even though the risks that they're doing may be overblown. So what are the options out there, right? I know we're running really close on time, right? You can do no domain controllers in the cloud and just do everything over the network. That's painful for everyone, right? As soon as that network link goes down, you have no environment. AWS has a managed Active Directory service. This is region specific, right? So you deploy this in one region in 2 availability zones in that region. If you're doing multi-site VMC, it's probably not a good solution, or you're going to have 4 of these with 4 external trusts, and it gets painful to manage. You can do a resource domain or resource forest in VMC. The challenge with that, again, your network goes down, you lose authentication. Let's not talk about read-only domain controllers, because you lose your network, you can't provision desktops, and you can't authenticate unless you cache your credentials. At that point, why not just do a full domain controller?
Lesson learned, just do the full domain controller.
Do the full
Honestly,
domain
save yourself the
controller.
hassle.
It's going to save you a lot of time. You can easily justify it, right? The reason for that, AD service availability is a huge reason for doing this, right? If you lose that service, you lose your environment. And networking also plays a part, right? So making sure you have good performance. All right, we're going to skip multi-site image management because it's an old problem that we've all had, and nothing new here except automate.
On that note, we are trying to fix it. Bear with us.
Yeah. File services, again, locality versus ongoing operational costs versus resource consumption. You need to have file services close, especially if you're doing profiles to get good login performance. If you want to put your file servers in EC2, there are networking limits on some EC2 instances that may throttle your bandwidth, which may increase your login time. And if you're using DFSR, you pay for all outgoing bandwidth. So just something to keep in mind, if you're replicating out of VMC, it's going to hit your bill. If you're using VMC as a DR site, you can replicate in, and they don't care, they're capturing your data.
It's free.
Amazon also just announced FSX for Windows File Server. It does require the Amazon Managed AD service, so it will require some sort of external trust. It's multi-AZ, but not necessarily multi-region. To network between regions, you need to have a transit gateway and the complex networking, and it doesn't really replicate content back and forth on-prem.
So yeah, just on the native AWS services, as Sean pointed out earlier, just because you can doesn't mean you should. If you want to use the Amazon load balancers, use the network load balancer type, not the application. The application type load balancer, you cannot change the cookie name, and if you have a load balancer front of the UAG and Horizon, it just gets confused and won't work. So networking load balancer. But in that scenario, you do need an internet gateway in AWS to allow the traffic into the UAGs. You will have incurred charges there because traffic is going from the SDDC down through VPC, and firewall rules will have to be in place in both directions, making it more trickier to do. And just on GSLB as well, remember we talked about you can send traffic wherever you want based on a number of different options. Just bear in mind that with the cloud pod architecture, there are some scenarios where a user might come into one pod and get redirected elsewhere. Home sites are a primary example of how that can happen. Just be very, very careful in regards to that one. And in regards to RDS, provisioned in the same availability zone as but kind of similar to Active Directory, and ensure that availability zone is actively connected to the SDDC. Yeah. But once you have done that,
Yeah, one thing when testing out RDS with Horizon, the first time I would provision an RDS instance, I would select my availability zone that was where my SDDC was, and it would provision it somewhere else.
Amazon knows better.
Yeah. So yeah.
Okay, and on additional resources, just at the end of this deck, there you go. There's lots of stuff up on Tech Zone in regards to VM Cloud and AWS and Horizon running on it. We have some published information on how this can all be achieved. Hashtag VMware on AWS and VMware Cloud on AWS is where they can get the social marketing people.
Right. And then just to recap that KB article, 58539. So if you're interested in Horizon 7 on VMC, that's the KB to take a look at. And I think we're out of time for questions.
But you'll find us outside.
Yes.